Okay, I think let's start. So, hello everyone. This is Kumaravel here. I am the founder MD of my VAct Technologies, uh, Coimbatore. We have offices in Coimbatore, Chennai, and Hyderabad. So, a little bit about me. So, I have 24 years of experience in product development, project management, dealing with many product lines like Timesys products and Microsoft products. So they're all into real-time embedded systems. Worked in many companies like Timesys, Microsoft, and Dutch Babcock. Embedded services. I've been proficient and have delivered a lot of products and services in embedded CAD/CAM and Eclipse-based technologies. So most of the tools now coming on the Eclipse technologies, like if you take uh, STM Cube ID and for Renaissance, Fujitsu, all the IDs now, because Eclipse is an open source and all the tool chains and everything is integrated, and they are selling is as free tool, free integral development environment. It's called IDE. So that's a little bit about me, about the company. If you see, like VAct Technologies, we are providing embedded services for many OEMs and tier 1, tier 2 companies. If you go to our website and see the clients, you can see a lot of them working on automotive domain. So this is about the first class introduction. What is the course content? So this is about CAN, controller area network. It's a protocol. So we will be dealing with introduction about CAN and what are the CAN formats you have. You have two formats. One is standard frame format, another one is extended frame format. And then what are the layers of CAN protocol, and what are the types of errors in a CAN protocol. And we also will be touch base on CANOE introduction, how the tool looks like, and how we will be writing the capital scripting and things like that. And you will be you will be at the end of the session, you will be able to do the database creation in vector tools like CANOE. And you also will be doing the panel designing where you will be designing your own simple cluster, and you will be writing a couple script, and you will be connecting the switch to the LED, and you will be able to toggle the LED using the switch and things like that. So believe me, this is the most exhaustive course available in the market, because nobody teaches so exhaustively. That the format and everything is put up in such a way that the insights of the overall CAN with the tools and the couple programming will be available on this program. Okay, this program normally this will be handled by Pujari. So today she is not available, so I am taking the introduction. So she is working in a bigger MNC in an automotive domain. So she has like 5 to 6 years of experience in this domain. So predominantly she will be doing all this. And so as I was telling you, after completion of the course, you will be knowing how to do the scalpel scripting, which is more wanted in the market right now, scalpel scripting. And then we will be dealing with SDLC and STLC, software development life cycles and software testing life cycle. So what is the difference, and what it needs to be, and things like that. And in SDLC, we will be touch base upon waterfall model, VV model, agile methodologies. So, and what is the unit testing? What is in unit testing? There are like different types of testings are available. One is integration testing, one is system testing, one is user acceptance testing, and then UDS, Unified Diagnostic Services, and what is service IDs in UDS, and what is a negative response code on the structure of UDS, an introduction. We'll be giving a little bit introduction about LIN protocol as well. LIN is again another protocol like CAN. Okay. So anybody can tell me what is a protocol? Just want to make it interactive. Anyone?
Yes, convenient rules.
Okay. Any other explanation?
Can say like set of guidelines which we should follow.
Okay. Sounds good. Okay, the protocol is set of rules which makes communication between two machines effectively. That's how the general definition is, as you told. Like, okay, once we talk in English, okay, yeah, I understand, you understand. So that's kind of a set of rules we have to follow. So protocol is like a language for the machines. Okay, that's what it is. So there are a lot of different types of protocols. There are one is low level protocol. So what is a low level protocol is like to transmit bits between two physical connected machines or networks. Example will be CAN, LIN and Ethernet. Okay, these are all low level protocols. So medium level protocol, you can say like Bluetooth and internet protocol. These are all medium level protocols, examples. And then higher level protocol is a HTTP, where heavy exchange of data takes place. So this is a high level protocol. Okay. So CAN is a protocol used in modern day vehicles. So you can see the ECUs available now in modern day vehicle. Can anybody tell me how much ECUs you believe that it will be in the modern day vehicle? Any numbers? 1, 2, 10? So almost 70 ECUs are available in the modern day vehicles. Okay, so I think there is you have I have the picture in there. You have like night vision, you have ABS, and then steering control, and then braking system, and you have body control, infotainment. You have a lot of things. Even tire pressure monitoring is there. There are a lot of issues now make up a car. So all the intelligence, everything is now even now there are most of the cars are coming up with ADAS, automatic driving assistance systems, and latest technologies like I mean IoT. For IoT, you have a lot of sensors and other things integrated with ECUs and things like that. So the modern day vehicles becomes very complex. Okay, with a lot of okay. Can you imagine wiring without a CAN network for all these ECUs? It will be something like this, which will be very cumbersome. And if there is any problem on the vehicle, to rewire it or to understand the fault areas and fix it will be a very tough task. Okay, so this is how before the CAN, the wiring was because you have to run the wires from one ECU to another ECU so that everything will work fine. So, but now today's CAN is simple. It's like a two-wire communication where all the ECUs are plugged in, and it will be there will be only two wires which will be going from front to back. Okay. So what is controller area network? So this is a protocol developed by Robert Bosch in 1983. So CAN is a two-wired half duplex high-speed serial network technology, asynchronous and multi-master communication protocol. Okay. So can anybody tell me what is half duplex? Sorry. What do you mean by half duplex? Okay, half duplex means like only one person can talk. Example will be a walkie-talkie. You can see the police will be using a walkie-talkie. Only one person can talk, but others can listen. Okay. So if it is a full duplex, it will be both persons can talk. For example, what you can tell, telephone. Telephone will be a full duplex communication. Okay, the communication between, if there is only one person can talk and other listens, it will be a half duplex. So CAN is an half duplex high speed serial network. Okay, it's a serial communication protocol. It's an asynchronous protocol. What do you say? What do you mean by asynchronous? This is very, very important. A lot of interview questions will be based on this. What is a CAN? Is it a half duplex? Is it a full duplex? Is it synchronous? Is it asynchronous? Why you call asynchronous? Why it's called synchronous? Is it a single master? It's a multi-master. This is a very important points are the most of the questions in CAN will be resolved on this. Okay. So what do you mean by asynchronous protocol? What is synchronous and asynchronous? Okay. Synchronous is nothing but it depends on clock. Okay. Sync is the word. Okay. You have to sync using the clock. But asynchronous means it does not use the clock. So it's an asynchronous communication, and it's also a multi-master communication. It's not, I mean, nobody is the master here. It's all every node. So every ECU we call it as a node. Anybody connected to the CAN bus will be called as a node. Okay, so every node thinks I am the master. Okay, nobody is slave here. So multi-master communication protocol. Okay, and CAN protocol is a CSMACD. What is that CSMACD? Carrier sense multiple access collision detection protocol. Okay, so carrier sense means, see, once if there is a half duplex, there could be a scenario where the two persons can talk, and there could be a reason there could be a reason to collision or making corruption. Okay, so making the message corrupt. So here it is not possible, because it's a carrier sense multiple access collision detection technology is there, because it's a message based priority protocol. We'll be seeing in detail in later slides. Okay, and this is another important question. Most of the people will be asking what is CAN 2.0A and 2.0B. So the CAN 2.0A, the latest specification from CAN is CAN 2.0. Okay, so it has two variants. One is 2.0A and 2.0B. 2.0A is nothing but is a 11-bit identifier. 2.0B is a 29-bit identifier. So that's the only difference. They also call 2.0A is also called standard for standard CAN, and 2.0B is also called 600 CAN. So we'll be seeing the CAN formats and things like that in our later slides. Okay. So what is the speed of a CAN bus? Okay. So the speed in a CAN bus can vary, depends on the length, how much distance it has to travel. As long as it is going to travel, the speed is going to reduce. Okay. So you can reach up to 1 Mbps for less than 40 meter. Okay. For longer network distance, it could be like 250 kilobits. So if you're having 500 kilobits, it's supposed to be the high-speed CAN network. Okay, high-speed CAN network means 500 kb. So that's what. So this is why CAN bus is predominantly used in automotive, because automotive is less than 6 meters. So the communication can be faster. Okay. CAN or controller it is basically used in communication among different devices in low radius regions such as automobile, as I told you. So what are the uses of CAN? So uses of CAN is multicast reception. As I told you, one person will talk, other people will listen. Okay, so multiple receptions are possible. Whoever is intended for the messages, they will take, others will ignore. Okay, that's how imagine it's like in walkie-talkie. Okay, if an SP is giving an instruction to an B11 station in Bangalore or Koramangala, for example. So then it means that only that guy will take the message and he will reply. So that's predominantly multicast reception. Everybody can receive, but only the message will go to the right guy. Okay. So error detection is possible in CAN. That's important because it has to be reliable. It is going to be used in automobile domain. So we cannot, we will not be able to do the error. There should be a mechanism to detect the error and get the things back once again. So that's important. Another one is configuration flexibility is there and reliability is there. So we will all be seeing what is there in next slides. So these are all the layers of CAN. So if you see layers, predominantly you will be using application layer, data link layer, and physical layer. So all other representation layers, session layers, transport layers, network layers are all built inside CAN stack. Okay, so most of this you will be using the 3 layers. So the layered architecture consists of 3 layers. One is application layer. Application layer will provide network access to the user. Data link layer is responsible for message transmission, reception, and error handling. Okay, and physical layer is responsible for bit encoding and bit decoding and bit transmission. This is what most of it is. Okay, so this is how a CAN bus will look like. On the top down, you can see there will be 2 lines, 2 wires, nothing but a twisted pair of wires with CAN high and CAN low signal, which will be terminated and at the each ends with an 120 ohms resistor. Okay, it's a simple 2-wire communication which can be you can make it in your home. So on top of it, how to if you want to send a message in the CAN, obviously you need a CAN controller and a transceiver. Transceiver is nothing but transmit and receiver module. Okay, so on top of it, a microcontroller is there. So a microcontroller gets the input from a sensor, for example, ABS. Okay, it gets the ABS sensor, gives the data to a microcontroller. Then microcontroller gets it does all the calculations and it sends the actual value to the CAN controller. So the CAN controller send the data to the transceiver, which the transceiver's work is to put the message on the canvas. Okay. So you can see there is 2 modules. So this is like this is a node A and node B, you can call. So there are 2 nodes connected here in the canvas. So this is how things will be. We'll be seeing most of the CAN nodes from here on. So when you are seeing each and every node has this kind of infrastructure. Okay, it has a microcontroller. See, in the second node, you can see CAN controller. Most of the microcontrollers now built for automotive has the inbuilt CAN controller in it. Okay, So even what we have developed, see one more thing. This is there are a lot of we have a lot of programs here. One of the program is this program is completely we are dealing with CAN, CANOE, and couple. Okay. Apart from this, we also have another embedded training program where you will be actually we have a customized board, STM32 board, where it has two CAN channels. You will be writing the messages. You will be creating the messages. You will be sending the messages to the CAN bus, and you will be receiving it and seeing it. Okay. So that's so if you see this in our STM32, the CAN controller is inbuilt into the microcontroller. You need only the transceiver to send the data to the bus. So these kind of microcontrollers are available right now. So CAN frames, there are 4 frame types. It's very easier. Obviously, for a frame, if you need to send a data, then it needs a data frame. So it carries data from transmitter to the receiver. So that's primary responsibility of a data frame. And second, remote frame, a frame requesting the transmission of a specific identifier. When a remote node needs a specific data, it sends a remote frame which requests the transmission of the specific message. Okay, for example, if you are asking me, okay, in an airbag system, if the airbag if the airbag ECU wants the update from an body control module whether the seat belt is connected or not. Okay, so it sends a remote frame asking the body control module whether the seat belt is on or not, or connected or not. Okay, so it sends a remote frame with that particular specific identifier, and it gets the data. So that's how the remote frame works. On an error frame, obviously, if there is an error, the frame transmitted by any node detecting if the node detects an error, it sends an error frame so that the sender will again try to send the message. Okay, and there is an overload frame. This frame is to inject a delay between data and a remote frame. So if a data is sent and suddenly there is a remote frame, there is a remote request from another node to make the bus complete the communication. There is an overload frame is there. So there are four types in the CAN network. So as I was telling you, standard frame format is a format of 2.0A. Okay, it's a standard frame which will be predominantly it's a 11-bit identifier. It starts with the starter frame which will be 1 and then 1 bit and then 11-bit identifier and then RTR and then IDE, then R0, then DLC and data. And then CRC and acknowledgement and then end of which will be 10 bits. I'll be dealing all these things in detail in our next slide. Okay. So extended frame, if you see, we have seen it's nothing but only the identifier will be having 32 bits. Okay. So everything is same apart from that the identifier will be a 32-bit identifier. That's the CAN 2.0B. Okay. So SOF. So I was telling you we'll be dealing later. So the SOS is the start of frame. Message starts from this point. Okay. So identifier means it decides the priority of the messages. So the lower the binary value, higher is the priority. Okay, so for the standard format is 11-bit, and if it is an extended format, it is a 29-bit. Okay, so RTR, remote transmit request. It is dominant when information is required from the another node. Each node receives the request, but only that node whose identifier matches that the messages is the required node. As I was telling you, when in a walkie-talkie, once the SP is talking, only the person who is supposed to get the message, he replies back. So similarly, whoever the messages will be received by everybody, but only whoever matches that identifier will be replying back. Okay. So ID single identification extension. If it is dominant, it means that standard can identify with no extension is being transmitted. So ID, if it is dominant, it is a standard format. Okay. Or reversed bit. And then DLC is the data length code. So this defines like how much data you are going to send, how many data, whether it is a 1 byte or it is a 10 byte or a maximum 64 byte you can send. Okay, that's an important question in the interview. So you can send till 64 bytes. So it defines the length of the data being sent. So the total DLC bit is 4 bit. Okay. And data is, as I told you, up to 64 bit of data can be transmitted. And then CRC, cyclic redundancy check. So it contains the checksum, number of bits transmitted of the preceding application of our error detection. So this is how the error detection happens. So apart from that, there is an acknowledgement. It is for a 2 bit. If it is dominant, its accurate message is received. And end of frame, EOF is end of frame. It marks the end of the CAN frame, the bit stuffing. So all this what I was talking to you is here. If you see SOF, identifier. So if it is an extended format, you have 29-bit identifier, or else it is 11-bit identifier. And this is RPR, this is R1, R2, DLC, and data, CRC, and until end of file. Okay, so this is how, this is what we have explained. So the frame format is very important. Yeah. This is again shown in a tabular column, standard, and because here we say the length of bit, how much length of bit is here. So SOF is 1 bit, and then arbitration field is identifier, which is 11 bit with RTR 1 bit. So all these things is available for standard format and extended format. Okay, coming back to the arbitration. Okay, so this is a most important factor in CAN messages. How one node is talking and other nodes start listening. It's all based on the identifier. If you see the identifier, so once the state of SOF for node 1, node 2, node 3, it's all low. Okay, start of frame. All three messages trying to send a message. Who gets the message, who gets the canvas depends on the arbitration. This arbitration. Okay. So this arbitration, if you see in node 1, you see it's the 10th bit is low, high, and node 2 also high, node 3 is also high. And 9th bit also high, high, high. And 8th bit is low, low, low. And then 7th bit is low, low, low for the node 3. And in 6th bit is high, this is high, this is also high. 5th bit low, this is high. So, low, and this is high, and this is low. Okay. So what this means is, these two are competing now. This will go to the listen mode from here. You can see from here, it will start going to the listen mode. Okay. So after that, these two, this is high, this is high, this is high, this is high. Here, this is high, but this is low. Priority depends, as low as your identifier, you will get the CAN bus. So priority will be based on your lowest number. So this is low. So this will go to the listen mode from here. Okay. So this is how the node 3 will get the bus and it will start sending the data. Okay. Any doubt? Okay. I'm giving you an exercise. At least you try to tell me, who gets the bus between, this is the node A. This is node B. And somebody tell me who will get the bus between, if there is, if node A and node B is having this kind of messages.
Node B.
Okay, good. Can you explain why?
It is working with wired and logic. Low is getting higher priority. Which one is lowest value? It will be taking to win the arbitration.
Okay. So if you see, this is obviously FF. So this is lesser than compared to this because there is 2 zeros here, right? So this will be a lesser number than this. So obviously B will get the this one. So now tell me in node A, B, C, who will get the data? I mean, canvas.
Node C.
Node C. Okay. Good. Now
Node D.
Node D will get. So that's as simple as that. Okay. So whoever is lesser number will have the most highest priority. Okay. That's how the CAN is developed. This is an important question again in the interview. How arbitration is avoided. I mean, how a collision is avoided. Okay. So that's the basic introduction about CAN, and we will be okay. So what are all the CAN applications? Right now we have studied, like we have seen an introduction about CAN, where it is used, what is the how it is avoiding arbitration, collision, all those things. Where applications? So obviously it is predominantly used in automotive because it gives a lot of advantages, which I will be giving you in the next slide. So it's used in passenger vehicles, trucks, buses, agricultural equipments, and electronic equipment for aviation and navigation. It is used. Industrial automation, they are starting using industrial automation and mechanical control, elevators, escalators, building automation, medical instruments and equipment, model railways, roadways. So all it is used. Okay. Ships and other maritime influence. So what is the advantage of CAN? Okay. CAN is advantages because it's very low cost and architecturally it is not very complicated. Okay. And not only that, it is easier to upgrade. Okay. So for example, if there is an ABS ECU, and if you want to add a functionality and plugin, you can just remove that ECU and add the new ABS ECU, because it's all based on the message-based communication. It's not based on the identifier or something like that. So easily it can be removed and added. Okay, that's an important point. It's a low cost and easier upgradation is possible, and it's very efficient. It's, as I told, you messages to others are ignored. Whoever is intended recipient only gets to receive the message. So it's very efficient communication. Only one message on network, and corruption avoidance is they are using CSMDA CD technology. So only one message on the network. It's an half duplex, as I told you. That's what it means. Only one message. So only one CAN node gets the CAN bus. Okay. So it's very efficient. It's also it's also very reliable. Okay. The CAN specifications has 5 level of error checks. Okay. So the CAN protocol is used in a place where the failure is not an option. Okay. For example, in an automotive, in a car, when you are traveling and if there is an accident, and the airbag has to open to airbag has to open to avoid life risk for the passengers and the drivers, right? So that's the CAN is a reliable message protocol which is used in most of the for most of the automotive here. Okay, and it is a robust. What means robust? Okay, most of the high-speed electrical, most of the high-speed data network are prone to electrical lines when they are going near electrical lines. Okay, but the CAN is resistant to electrical signals and electrical disturbances. Okay, if nodes can work on extended, yeah, some of the nodes, like if you want the node to be working on probably like 150 degrees centigrade or 800 degrees centigrade, you can build one using the extended components. Okay, so automotive components now comes with higher temperature and things like that, because it's not like whether you are sitting and going, only you are sitting in ACs in your car, but all these ECUs are working under extreme temperatures and extreme humidity and a lot of other factors. Okay, so it has to be robust. So you can build one a node an ECU using the CAN network. That's what it is. So it can be used on the extended temperature and also fault resistant varieties. So most of this, some of the nodes you can, if you need, you can develop a fault resistant ECUs. Okay, and it has been a flexible. It will be very flexible because it's a message based. It doesn't have an individual identity. Okay, so for example, today if it is called like Kumaravel, and tomorrow it's a Pujari, then replacing Kumaravel with Pujari or Pujari with Kumaravel is very difficult. But here it's all message based. So you can easily plug out the old ECU and plug in the new ECU with a extended functionality, with a more messages, more signals, more things there. Okay, so it's very flexible. New nets can be easily added or it can be removed. If you don't want, you can remove it. So that flexibility is given in the CAN. Okay, so that's about CAN. So now we are going to see about CANOE. Okay, so we have now seen what is a protocol, what is a CAN protocol. So what is the advantage, disadvantage, what is an arbitration, all those things. Okay, now physically how we can see generate the CAN protocol and see. Okay, so there is only one tool in the market predominantly used by OEMs. Okay, so that tool is called CANOE. CANOE is from Vector Informatic, Germany. Okay, So this Canoe is a development and testing software tool from Vector Informatics. Okay. Software is primarily used by automotive manufacturers, ECU suppliers, and Tier 1 suppliers, Tier 2 suppliers, everybody. Okay, for development, it can be used for analysis, it can be used for testing, it can be used for simulation, it can be used for diagnostics, and it can sometimes used for startup of ECU networks and individual ECUs. So I can tell you one application where one of my customer is using. Okay, Canoe. They are my customer is producing instrument clusters. So for testing the instrument clusters, you don't really need to have a vehicle. Like if that cluster is going to get inside an ECU, car, then you don't need to bring the car there. What you really need to do is you have to create some capital scripts inside the Canoe where you will be sending the speedometer readings, odometer readings, trip readings, and petrol readings and temperature readings, whatever is available in the cluster. All these messages can be sent 1 million times, or the specification will come from the OEMs. Okay, if Volvo or GM or Volkswagen, whoever is has given the order for the instrument cluster, they give the specification, how many times it has to be tested and what all it needs to be seen and things like that. So in Canoe, you write a test script using CAPL programming to test it. Okay. So you put it on the, connect it to the Canoe. So I'll connect the instrument clusters, 2 or 3 clusters, and you put and you make it run for like weeks. So it will be doing like 1 lakh times or 1 million times as per the customer specification. And then it will be completing and it will be coming out and giving you the results. Okay. That's one typical example where in a testing you can use the Canoe tool. It's widespread used in large number of supported vehicle bus systems, makes it especially well suited for ECU development, conventional vehicle as well as the hybrid vehicles and electric vehicles. Okay, the simulation and testing facilities in Canoe are performed with CAPL, a programming language. Okay. I think that's about it. Then thank you everyone. The regular class will start from tomorrow. Okay.